Today's lesson is on solving two-step equations. We're going to use the same idea as one-step equations. We're just adding a step. You just need to remember about inverse operations, the operations that undo each other. Addition and subtraction undo each other, and the operations of multiplication and division undo each other. In our first example, we have 2y minus 3 equals 7. And when we're solving equations, I often will draw a line at that equal sign just to visualize that we will be moving our numbers across that equal sign. We want to get y by itself, so we have to undo the subtraction of 3 and the multiplication of 2. So first, you always want to try to undo addition and subtraction first and multiplication and division last in most cases. So in this example we have the subtraction of 3. To undo that we need to add 3 to both sides. By doing that, the 3's cancel on the left side and it leaves you with just 2y equals 10, and that's 2 times y. So to undo the multiplication we can divide both sides by 2, which leaves you with y equals 5. Now, the cool thing about this whole unit is you can always check your solution. So, in the original, 2y minus 3 equals 7, check your solution by plugging 5 back in. What is 2 times 5? That's 10, and minus 3 is 7, so it checked and it worked, so therefore we know our answer is correct. Example number 2, m divided by 4 plus 2 equals 10. So let's undo the addition of 2 by subtracting 2 on both sides. The 2's cancel out on the left side, and it leaves you with 8 on the right side, m over 4 on the left. So now that's m divided by 4, and the opposite of division is multiplication. So we're going to multiply both sides by 4. Cancels out the denominator, so m equals 32. Don't forget to check your solution. Plug your answer back in to the original. 32 divided by 4 is 8, and 8 plus 2 equals 10, so it checked. Negative 1/5 x minus 2 equals 4. Let's start this by doing the opposite of the subtraction of 2. We have to add 2 to both sides. So our 2's cancel out on the left. 4 plus 2 is 6, and then I have the negative 1/5 x on the left side. And if we're multiplying this x by a negative 1/5 by a fraction, to undo the fraction you can either divide or we can multiply by the reciprocal. And the reciprocal of negative 1/5 is negative 5. Or negative 5 over 1, same thing. So here, this cancels, and x equals negative 30. Don't forget to check. Negative 1/5 times 30 is, times negative 30 is a positive 6, and a positive 6 minus 2 equals 4. So it works. For this example, I want you to write the equation down and pause the video and see if you can solve it on your own. The one tricky part about this one is we have addition, and so the opposite of addition is subtraction, but since we have a negative 21, we're actually, how do you undo a negative 21? You'd have to add 21 to both sides. you should have gotten the answer that A equals 112. This next example is a little bit different, so we're going to do this one together. Now usually you always undo addition and subtraction first, but in this case, because you have a variable within the fraction, we're going to try and undo that fraction first by getting rid of the division by 2. So how do you undo this dividing by 2? We can multiply both sides by 2. What that does is cancels out the denominator and leaves you with just 12 minus x equals 5 times 2 is 10. Now, we want to solve for x, so you undo operations. And here's another tricky example. We have a subtraction sign here. And the opposite of subtraction is addition. However, look at what we want to undo. We want to get rid of a positive 12. So how do you undo a positive 12? You would have to subtract 12 on both sides. So if we subtract 12, our 12's cancel, but we still have a negative x left over on the left, and then 10 minus 12 is negative 2. When you have a negative x, you can think of it as a negative 1 times x. So to get rid of a negative 1 times x, we have to divide both sides by negative 1. So x equals a positive 2. Now don't forget to check your answer. 12 minus 2 is 10, and 10 divided by 2 is 5. So it checks. Here is the last practice problem before the story problem. So I want you to once again pause the video and try this one on your own. I hope you were able to get negative 6.4 as your answer. In this unit in solving equations, when we have a story problem, there's more to it than simply just solving it. You need to write an equation for the situation. And if you write an equation, you're going to have a variable, and you have to define that variable. What does the variable mean in your equation, and then solve the equation. So let's read this problem. Okay, so like 10, you're shopping at the mall with your friends, and you want to buy like one hat and several t-shirts. The hat costs $22.50 and each t-shirt costs $12. How many t-shirts can you buy if you have $75 to spend? So you are only buying one hat, but you're buying several t-shirts. So that one hat cost $22.50, but then you are buying more than one t-shirt, and the t-shirt costs $12 each. So $12 per t-shirt, and we have $75 to spend. So here's my equation, and then I have to define the variable that my variable x represents the number of t-shirts. So define your variable, write the equation, and now we're going to solve the equation, solve for x. So I'm going to subtract $22.50 on both sides, which leaves me with $52.50 left over for t-shirts. And now I'm going to divide $52.50 by 12. And I get that x equals 4.375 for x. But that's not really the solution I want, even though that's the solution for x. The question says, how many t-shirts can you buy? Well, you're not going to buy part of a t-shirt, and you can't round up because you don't have enough money. So your answer is, you're going to buy 4 t-shirts. So as long as you define your variable, write the equation, and then solve it, you're all good. So, pretty easy lesson. Good luck with the assignment.